Hello, Algebra 2. Okay, so today we're looking at 7.2 Day 2, Future Value Annuities. Okay, a future value annuity is a process of investing a certain sum of money on a monthly basis, like you're putting in money every month. And then you have an interest rate associated with it, and we'll get a future value out of it. This is how a lot of retirement accounts, college investment accounts look like. Okay, they're usually annuities. Okay, so we need to determine some things to do this. First, we need to determine our initial deposit and our monthly deposits. Okay, the number of deposits that are being made. The R, this is actually a little bit difficult to figure out. It's not just your rate of return. It's actually your annual percentage rate divided by 12, usually because you're talking monthly, or however many times you're doing it, usually monthly, and then plus 1. Okay? So the equation is in this form, S sub n, and that is called summation notation. You will talk about that in pre-calculus or 107. Whatever math class you take next year, you will be using some summation notation. Okay? So in order to simplify this, okay, we're taking a look at a question like this. Okay, again, an annuity. A deposit of $100 is placed into a college fund at the beginning of every month for 10 years. The fund earns 9%. Okay, now that's not just going to be your R. We have to figure out our R. Okay, how much will the account be worth right after the last deposit? Okay, so we have our $100 initial deposit, so that's going to be our A sub 1. We have 120 months of deposits being made, so our N will be 120. Okay, to find our R, we're going to divide that by 12, divide our rate by 12, okay, because that's per month, and then add a 1 to that. Okay, so that'll be, because it's a growth, so 1.0075. Okay, so let's move up, take a look at this. We have to remember our PEMDAS, since there's some kind of interesting strokes you might make on your calculator for this. But the first thing I do when I'm working through this on my calculator is I take 1.0075 to the 120th. Now I'm going to get some weird number. Then I take 1 minus that number, and usually I just go 1 minus answer, and it'll fill it in. Okay. Then I'd multiply that times 100. Then I'm going to divide it by 1 minus the R. Okay. And this one, take a look at it. You put in $100 a month for 120 months. Okay. And we end up with $19,000. Not too bad. Let's take a look at this on how I'm working with it. Okay. I'm looking to retire at some point in my life. And let's make it even numbers and looking good. 70 years old seems like a good time to retire. I hope to retire a couple years, maybe before that, but I'm actually in no hurry. I like my job. Okay, here we go. I've been putting in $50 a month into a retirement account. It earns, over the course of the life of the account, 8% APR. I started doing this when I was 25, and I plan on retiring when I'm 70. How much money should be in the account when I retire? Okay, so we're going to do that with 8% first, and then we're going to see how much this percentage plays a role in this whole thing. Okay, so at 8%, what are we looking at here? Okay, well, what I like to do is figure out my R first. R equals 1 plus 0.08 over 12. Okay, so I'm on my calculator now, 0.08 divided by 12 equals, and then I put 1 plus second answer. So I've got equals 1.006667. Okay, that 6 is going to just keep going out. Okay, so I'll round that to a couple decimal spots, but we're going to at least get 667 in there. All right, so that is our R. Okay, so I'm going to say summation notation, S. My N, let's do this. N equals 12 times how many deposits am I going to make? Well, that's 50 years. From the time you're 25 to the time you're 70, it's 50 years. So that's 50 years, right? So that equals 600 deposits. Okay, so that's our 600 deposits equals, that's our N. Okay, so A sub 1, that's my monthly payment, $500 a month. 1 minus 1.00667. Okay, and then to the N is 600. In the exponent, that's big time. All right, over 1 minus 1.00667. Okay, now you might be looking at this going, okay, that's kind of weird and all that. We're going to get a negative over a negative, okay? And then you know a negative over negative equals a positive. Okay, let me talk about how I'm going to do this on the calculator. I'm going to take 1.00667, okay, to the 600. I already have that on my calculator, 1.0066666667. Okay, so I'm just going to keep that on my calculator, go up arrow, right, for my exponent and go 600. And I get a number like 53.878, right? I take that and I say 1 minus that. So I go 1 minus that answer, okay? And I get negative 52.878, okay? I'm going to take that times 500. Okay, so my numerator is like negative 2643.9.09159. That's what's in my calculator. Okay, that's going to be over, right? 1 minus this is 0.006667, right? Okay, rounding going on there. Okay, so I'm going to divide by 0.006666666667, right? Okay, now I've got, oh, excuse me, I was supposed to divide by a negative. Well, I'm just gonna have to change my numbers. This should be a negative, right? Okay, so now I've got, I think I messed up. Let me check this. 1 minus 1.00667. Yeah, okay, so I'm good with putting the negative in there. I end up, after 50 years of working and putting in $500 a month, with $3,965,863. Bang, bang, look at that. Ballin'. Okay, and 0.74 cents. Keep the change, baby. Walking out with almost 4 mil. Okay, so that's at 8%. Those are big numbers. I like it. I like where I'm going. Okay, hopefully, I don't know, stock market, whatever. You can't really determine 8%, but that's actually kind of close over 50 years. It usually does something like that. Okay, now let's take a look at if I did this at 4%. Okay, so everything's going to stay the same except for this number right here. Okay, my R is going to change. All right, so let's move this up, and I'm going to actually zoom down so I can use some of this. Okay, so my S sub 600, right, and equals 500, 1 minus. Now my R for this one is going to equal, I'm doing the 4%, 0.04 over 12. Okay, and then plus 1. Okay, so 0.04 divided by 12 equals 0.03333333, right? And then plus 1, and that's my R. My R equals 1.0033, line over the top. Okay, over 1 minus 1.0333. Okay, what did I forget? Well, that N up there, that is to the 600. That's what's happening. That's big time. Okay, so let's look at our equation right now. Okay, so what's changed? The only thing that's changed between the 8% and the 4% is this right here. Well, I think we're going to see a pretty big change here in our answer. Okay, so I'm going to take that decimal. I'm going to take it, our 1.00333333, take that to the 600. Okay, that equals 7.3. Very different from what I had. So I'm going to take 1 minus that answer, 7.3645, whatever. Okay, I get negative 6.36. Okay, times 500. Good. So my numerator looks like this now. Negative 3182.2606, something like that. Okay. 1 minus 1.333. So I'm going to say divided by, open parentheses, 1 minus 1.00. And I'm just going to hit that. Ooh, I forgot that extra 0. That's supposed to be one more 0 there. 3333333. Close it. Hit it. Now I'm walking away with, on this one, walking away with $954,678. 900 grand and 30 cents, I guess. I might keep the change if that's it. If I'm only getting 4% on my retirement account, that's not okay. Look at the difference. 8%, almost 4 million. 4%, basically just about $1 million. Okay? So those percentage rates have a heavy impact on your money. All right, very good. Get these 2 lessons done by Friday. Hopefully, take a look at it. Should be good to go. Show your work. See you.